Good evening and welcome to the AOPA Air Safety Institute presents Flight Deck Tech Strategies for Optimizing Modern Avionics. Tonight it's episode 3, What Went Wrong? My name is John Collins. I'm the manager of aviation safety programs for the ASI, and I'll be your host and presenter for this evening. Before we get started, just a few reminders. You see them up on the screen here. Please mute your mic and turn up your sound. Of course, during the broadcast, we cannot troubleshoot any technical issues, but if you log out and log back in, we found that generally works well in resolving those issues. We will have a question and answer time at the end of the webinar. Please use the question feature to do that. If you are operating off of a laptop or desktop computer, you'll probably see this off to the side. Just click on the question mark. That will bring up a question box where you can type your question and then hit send. If you tap it again, it should go away. If you're operating off of a smartphone or an iPad or tablet, you'll probably see the question mark up at the top of your screen. Again, just go ahead, click on that, type your question, and hit send, and then tap it one more time. We'll clear it off the screen. If you want to watch this again, we will have a recording of the tonight's webinar. It will be available tomorrow on the airsafetyinstitute.org website. Just go to airsafetyinstitute.org/webinars, and you can get a copy of that. You can download it, take a look at it, share it with your friends. Also, this webinar qualifies for Wings credit if you signed up or registered for the webinar using your FAAsafety.gov email address. We will automatically give you credit, and that will appear in your Wings transcript probably Monday or Tuesday of next week. If you're not sure if you signed up with your Wings email, by all means, go ahead and give that to us in the questions, and we'll make sure we add you to our list. So without further ado, let's go ahead, let's take a look at what we're going to talk about tonight. Whoops, a little too fast there. So tonight we're going to be talking about how avionics play a role in accidents. We're going to take a look at 2 accident case studies where avionics may have had an impact on the outcome of the accident. We'll look at some prevention strategies. We'll talk about some key takeaways. We'll have our question and answer, then our closing, where I'll also tell you how you can get your AOPA ASI webinar badge for watching tonight's webinar. So avionics, are they causal or contributory to aviation accidents? We seldom see them mentioned in the probable cause and findings section of an NTSB accident report. In fact, many times it's buried down in the details. Sometimes you have to go into the docket to take a look at some of the information contained related to the avionics involved in an aircraft accident. If they're mentioned, they're usually contributory. And the fact that they're mentioned at all, the fact that they're looked at, tells us that we do need to know our system. So we have to go ahead and take a good look at what's going on, get into the documentation, take some training, and understand how things work for us. Our first accident tonight, occurred back on August 29th in 2020 in the wee hours of the morning, 1:33 a.m. Central Daylight Time. A Cirrus crashed on an RNAV approach into the Lawrenceville-Vincennes International Airport. And as you can see in the picture there, it was consumed by fire during the crash. Not a lot left of it. The aircraft was piloted by a private pilot who had an airplane single engine land certificate with an instrument airplane rating. At about 667 hours of total time, 582 of that in PIC, 45 hours in make and model. And actually that make and model is in the accident aircraft. 107 hours in the last 90 days, 27 hours in the last 30 days. This is obviously a very experienced pilot. Current has a lot of experience in the aircraft. In the 45 hours of make and model time, there were 9.1 hours of night flight and 1.8 hours in actual instrument time. He's also flown 7 approaches prior to the accident flight. He had his last instrument proficiency check back in April of 2020, so he was certainly current there. And when he purchased the aircraft, he also went through the Cirrus Embark training program, which consisted of 4.5 hours of ground training and 12.2 hours of flight training. So it's fair to say that he was pretty well trained in the aircraft. I think everything was good there. And he had a lot of experience and was not a rusty pilot or a rusty instrument pilot at all. The aircraft was a 2007 SR-22 with a 310 horsepower engine It had an Avidyne DFC-90 autopilot, and it was purchased 2 months prior to the accident flight. So in those 2 months is when the pilot put in the 45 hours of flight time. The day before the accident, he flew down to Florida and had some avionics work done, and he swapped out a Garmin 430 WASP box, and he replaced it with an Avidyne IFD 440, and that's what he flew home with. He flew home the day of the accident. Actually, was in the evening prior to the accident leg. The weather at his destination airport, he departed out of Tampa, Florida, and he went all the way up to Sullivan County Airport in Indiana, and then was flying back south down to his home airport in Lawrenceville. The weather in the early hours of the morning when he landed in Indiana, he made an instrument approach, but it was marginal VFR up there and marginal VFR down at his destination airport. As you can see there, 6 miles in mist with a few clouds at 200 feet, broken clouds at 1,100 feet. The temperature dew point spread should be 22 and 22, so it's right there even with each other. That's an indicator that things are probably going to get a little bit worse. And over the next half hour, it in fact did. If you were to look at the weather reports coming out of Lawrenceville over the next 37 minutes, up to the time of the crash, it was steadily decreasing in visibility, and we went from a broken ceiling at 1,100 to a vertical visibility of 200 and a half mile in fog. Calm winds, which means that there's probably nothing going to be moving out there, so it's going to be very difficult to get in, and it's a very, very low IFR. So that's not a good thing to be doing. It's also at nighttime, and that could be a tricky way to try to get into an airport. As I said, he departed Tampa, Florida back at about 8 o'clock, 8:45, 8:46 in the evening, and flew about 4.5 hours up to Sullivan County, where he refueled. Sullivan County is on the eastern side of the time zone change, and he departed IFR at 2:11 Eastern time, flew across the time zone line, and actually was on approach into Lawrenceville. So when he contacted departure after taking off from the airport, they verified with him that he had the weather and the NOTAMs for Lawrenceville, and then cleared him for the RNAV GPS runway 18, starting at the initial approach fix of JEBDU. Once he got established there, they terminated radar services and told him that he could close his flight plan once he was on the ground at Lawrenceville. And there were no further communications between the pilot and ATC. Very quiet night, nothing to talk about. He's on his way into the airport. The ADS-B data shows that he departed on a climbing left-hand turn. You can see in the upper right-hand corner of the picture there, and he departed southwest towards JEBDU. It's a little wide on the turn at the intersection, but then tracked to the final approach fix at Lukme and descended from 2,200 feet down to 600 feet. And it looks pretty normal. I mean, it's, who of us out there haven't overshot a fix and tried to get back on our course? And it looks like he was getting pretty close to it as he was coming in closer to the airport. ATC, when they thought he should have been down on the ground, they tried to reach him multiple times, but were unable to. And it turns out that the aircraft actually descended lower than it probably should have, struck trees, crashed, and was consumed by a post-impact fire. Due to the fogginess in the area at the time, when rescue units were contacted to go out, they were unable to locate the aircraft due to the fog in the area. They couldn't launch a helicopter to go take a look for it. But an aircraft that was flying into Lawrenceville in the morning noted it, and we were able to direct search and rescue to the accident site about 1.5 miles away from the airport. In this next slide here, you'll see we've got the picture of the ADS-B tracks showing the descent there. It looks pretty normal all the way down until that last bit where he just descended a little bit too low on that final approach. You can see the approach end of the airport. There's runway 18 down at the bottom of the page there, and about 1.5 miles up is where that accident occurred. So what went wrong? We really don't have a good idea here, other than we know the airplane descended too low. The avionics memory was corrupted, or was not available because of thermal and impact damage due to the fire. They couldn't retrieve anything, so we don't know exactly what he was looking at, what he was doing in the last moments of the flight. Because of the severity of the crash, flight control continuity was not confirmed, so we're not sure if he had usable controls all the way in. The track would seem to indicate that he was not experiencing any issues with controlling the airplane or keeping it on a heading or on an altitude. What they were able to look at in the airframe, the engine, and the propeller, they couldn't find any evidence of pre-impact malfunction or failure, so it should have been a pretty normal flight into the airport. Very few clues to the cause of the accident, which is why I think the NTSB started to focus on the avionics involved in the airplane and possibly also the time of the flight. In their determination of probable cause, they state that the pilot's controlled flight into terrain as a result of his failure to properly execute an instrument approach and maintain clearance from trees in a night instrument meteorological conditions, and contributing to that accident was the pilot's unfamiliarity with a newly installed avionics system. It's very possible that perhaps he was distracted by something on the panel there, trying to figure out maybe the buttonology or the knobology. Very difficult when you move from one system to another and you haven't taken a lot of time to do that. We're not sure exactly how much time or training he had with that. And that's one of the questions that we've got when we look at this accident. We try to consider what's going on. How much training did the pilot have on the new GPS? Was he actually able to spend some time playing with it? Perhaps flew on the flight home from Tampa, was able to input his flight plan information. He made an instrument approach at his fueling stop, so he was able to load that, and he loaded the approach to come into his home base. So he had that information, but perhaps the buttonology was just different enough that maybe wasn't sure what was going on and had a question about it, might have been distracted by that. It's also very possible that flying in at night and in fog, might have seen glare and seen a reflection, thought perhaps he was closer to the airport than he was. And was there pressure to get home? This is an interesting situation. Flew down to Florida, had the avionics work done, flew back home, departed late in the day, 8:46 in the evening, flew all the way home, and then is trying to get back in. Would it have made sense to stay overnight somewhere? Perhaps. We don't know what he had to do the next day. We're not sure if he was trying to make a meeting or something like that, but the question then becomes, why put yourself in a nighttime low IFR situation with new avionics? In talking about this accident with some of my colleagues, there was a lot of questions about that. And in speaking with one of our You Can Fly ambassadors, Kay Sundaram out of California, when she gets a new piece of avionics, she takes some time with it. She spends no less than 5 hours flying with them in VFR conditions so that she can understand all the buttonology, what the steps are, how everything works, what the interconnectivity is between all the boxes and the other pieces of equipment in her aircraft. And it has some recommendations. We're going to talk about that a little bit later, but your personal minimums come into this as well. I know in other presentations that I've done where I've talked about personal minimums, you want to develop those, and you want to consider what the boxes that you're willing to fly in, and are you willing to take the risk of flying single engine at night? There are some people that don't. I had a former boss that had been a Navy fighter pilot, had lots of night flight time, night carrier landings, all that kind of stuff, but would not fly at night because the person he flew with the most was his wife. She did not like to fly at night. So their personal minimums, they were on the deck by twilight, and they were not flying at night, even though he had lots of experience and was safe, probably could have done it without any problems. But because of the comfort of the person he was flying with, he decided to have that as a personal minimum. And that's something to consider when you're creating your personal minimums. Our second accident case study occurred a year before, June 27, 2019. Again, it was an evening flight, 10:30 in the evening, and a Baron crashed into a residence returning to land at Fayetteville Airport shortly after takeoff. He'd taken off from the airport and was going to do some night currency work, and had some issues, and ultimately crashed into a residence. Unfortunately, there were people in the residence. One of them was killed, one of them was seriously injured, and the pilot did not survive the accident either. He was a private pilot with an airplane single engine land and a single engine sea and a multi-engine land rating and instrument airplane rating, so he has some experience there. 480 hours of total time. Not sure what the breakdown is of that, and I'm not sure of the complete recency of experience. Had a third-class medical that was issued a couple years prior, but was still within the currency for that. And so had some flying experience. We're not sure how much time he had in the multi-engine aircraft itself or in that specific make and model. But the aircraft was a 1979 E-55 Baron, had a Century 3 autopilot. It was coupled to an Aspen EFD 1000 EFIS with an AHAR system associated with. The weather on the night of the flight, it was a great VFR night. It was clear, 10 miles of visibility, light winds, and so seemed like a perfect night to go up and to do some night currency work. But there's some things that happened ahead of that flight that we probably need to take a look at. During a previous cross-country flight, about 3 days prior to the accident flight, when he was flying with one of his friends, there was a failure light that illuminated from the AHAR system, and it stayed lit for about 12 to 15 minutes. It started up during the run-up, and then it did not extinguish itself until they had launched. They were actually up in the air and along on their flight. They discussed continuing the flight under VFR conditions so that they could not have to worry about having a failure, and also the pilot enjoyed flying with his autopilot, and if that was not working, his autopilot wasn't going to work. But after 15 minutes, it went away. They were able to make the systems work. They continued on the flight, and on the return flight, it did not give them any trouble at all. But after they landed, the light reappeared again for a few minutes after cycling the avionics prior to the shutdown of the aircraft. So based on that, the pilot decided that he would take the aircraft into his avionics shop and have them try to fix what was going on with his AHARs. And on the evening of the accident flight, the pilot visited the avionics shop and was told that they were still in the midst of the repair. It hadn't been completed yet. They were waiting on some information from the manufacturer. And but if he wanted to take the plane, he could. The only thing that would be affected was that he couldn't use the autopilot. So it seemed like it would be okay to go fly the airplane. So then he decides to go fly it. He takes off from Fayetteville at about 27 after 10 in the evening. 2 minutes into the flight, he reports a problem to ATC and wants to land. And so, in essence, what he's telling him is he has some very heavy control forces and is really wanting to pitch down bad for some reason. They talked about which runway he was going to land on. He decided to land back on runway 4, and he's starting to turn into it, and the ATC is trying to talk to him, but they're not getting any response from the pilot. A witness on the ground noticed that the airplane veered sharply and then descended at a 45-degree angle just prior to impact. And again, unfortunately, that was into a house and some terrain there south of the airport. This is a diagram of the track of the flight, and you can see where he departed off the airport and was coming back around to land on the same runway, or on the opposite end rather, of the runway he'd taken off from. It was unfortunate that he was not able to overcome the forces there to keep the airplane flying. When the NTSB went to do their investigation, there were no readable instruments because the cockpit had been crushed so badly. All they had was a fuel gauge they could look at. They were able to determine that the gear and the flaps were retracted. They weren't extended at all. They looked at the trim tab actuators, and based on the positions of those, they indicated a full down tab on the left aileron, a little bit of nose left on the rudder, and more importantly, on the elevator trim tab, there was 10 degrees tab up, which equates to a full nose down trim. Obviously, he was trying to overcome those forces as he was trying to get back to the airport. They were able to confirm that the flight controls were working. They had continuity all the way across, and so it didn't look like there was anything that had departed the aircraft prior to the crash. They were able to salvage an autopilot programming unit and an engine monitor out of the debris, but those did not contain any usable memory either. They did find 3 autopilot servers that they examined, and those are those will play a part here in just a moment. We're going to talk about that. One of the things that they've noticed as they were doing the investigation, that there was an airworthiness directive that was applicable to this particular aircraft, and actually more specifically to the avionics displays in certain aircraft, which this one was listed, the E55 was listed in the AD and in the service bulletin. So this was prompted by reports of flight displays repetitively resetting in flight, and they would go out for a few minutes, they would come back in, and there were enough reports of them that Aspen actually issued a mandatory service bulletin applicable to all units that had a specific software version installed, and they required disabling the ADSB in before the next flight in IMC, or at night, or within 25 hours time in service, whichever occurred first. And we're not really sure how if this AD applied specifically to this unit, because the the NTSB could not determine if the software was installed on that EFIS due to the damage sustained in the crash. And the logbook did not show any entries showing where it was indicating any compliance or indicating that it didn't need to be complied with. So we're not sure how that affected that airplane there. Obviously, it looks like he'd flown it in IFR in between. We're not really sure exactly where that came out at. So the other thing that was part of the investigation that was noted is that in the POH for the aircraft, they talk about an unscheduled electric elevator trim, and that could an uncommanded pitch could be stopped by turning off the autopilot master switch, pulling the autopilot and trim circuit breakers, turning off the radio master switch, turning off the electrical master switch, pushing the go-around switch on the throttle grip, or pushing the test each flight switch on the autopilot controller. Not all of those may have been applicable to the particular to the particular autopilot system. And so in the POH is a note that is very important. I think it's something we should pay attention to. It's essential that you read your airplane flight manual supplement for your autopilot system and check each function and operation on your system. I know we get the supplements, they stick them in the back in the supplement section in the POH. We're aware of them, we look at them, but really how many times do we go in and look at them in detail? That's a question that, are we doing that? Should we be doing that? And the answer, I think, is yes, we should be doing that. We need to do that. It's important. When the NTSB conducted their testing, they found that the roll and trim servos did operate within design parameters, but the pitch servo did not. And that was very important. When the pitch servo was powered, it engaged, but it wouldn't disengage when the power was cut off. So that's important, that it disengages when power is reduced to it or removed from it. And it would only disengage if they manually spun or they bumped the clutch, then it would disengage. They found that the electrical cable was sensitive and that it was kind of intermittent. They think there may have been some broken pins within the cable there, within the connection, resulting in an intermittent motor operation. And then in testing the tension of the pitch servo, they found that it was 45 pounds, which is about 3 times or a little 3.5 times as much force as necessary, or as required rather, than the 13 pounds. So what happened was they determined that when the servo was last serviced, it was removed from the airplane, the castle nut was over tightened, and it had been removed and tightened, and it was tightened past where it had previously been, which was indicated by a mark, and that was off about 3/4 of a way around the bolt that it was attached to, and that there was a new cotter pin installed in there, and the tape over it was not matching up with the previous mark. In looking at the accident, they weren't sure if the autopilot, or if the pilot had engaged the autopilot and was trying to overcome it, or if he was testing it, or if because of some reason it just turned on, he may bumped the switch or something like that. Entirely possible. They're not sure what happened. They just know that he was unable to overcome the force. And going back to that AD that was that I mentioned previously, I do want to mention that the reason it was there because certain EFIS systems with that 2.9 version of the software, the EFIS would reset. It would go out and it would show a light for a couple of minutes, and it would reset, come back on. And so that was why that service bulletin was issued. That may have been part of what they were trying to track down when it was in for the 15-minute and the 3-minute lit bulb that or warning light that was on, and that was what they were trying to go after. The NTSB's probable cause in this accident: pilot's failure to disengage an uncommanded nose down pitch input, and contributing to the accident was improper maintenance of the pitch trim servo, which would have precluded a physical override of the pitch servo. So in this accident, some questions to consider. How often do you review and practice for an autopilot or a runaway trim emergency? If you're a corporate pilot or an air carrier pilot, you go in for training every 6 months and you run through a litany of emergencies, including these types of emergencies. As general aviation pilots, we might do that on an annual basis if we're taking insurance required training, or if we have set up a recurrency program ourselves. But generally, we check in with a flight instructor every 24 months for a flight review. Maybe we check in annually as we complete a phase of the wings program, but is this something that we look at? Do we take the time to go through those emergencies and run all the drills for them? Another question related to this accident: is it really wise to fly an aircraft that's still undergoing service for a reported malfunction? I know when I have a malfunction on an aircraft I fly here at AOPA and I report it, if it's a downable item, the airplane is down, I don't fly it, neither does anybody else. Coming back in to check it out and fly it just to go get some currency might be, wouldn't happen here, probably shouldn't happen in your flying, but that's a good question to consider. Is it worth the risk to go out and do that? Another question: do you know how your avionics systems are integrated and what information is going to other systems? If you go into that airplane flight manual supplement, in many of them you'll see that interconnected integration diagram that tells you where information is coming from, where information is going to, and as you read through the emergency section in there, the section 3 in the supplement where it talks about emergencies and abnormal operations, you can get an understanding of how that works. And if you don't understand how that works, maybe that's a good thing to discuss with your avionics tech at the next time you go in for service, or give them a call in between. And that, of course, leads into that last question: when's the last time you read through those supplements for the avionics and the other equipment installed in your aircraft? I know when I was a student pilot, I saw them in the back and I was like, oh, okay, yeah, sure, whatever. I'd look at them. I didn't see them in my airplane, but I didn't really consider them. Now, as a more experienced pilot and as an instructor, it's becoming more and more important to understand exactly what's in it, to go through those and really consider what is it talking about. What do I need to know as a pilot? So some of the takeaways out of this: we have problems when we talk about upgrading avionics. There is no real standardization across the OEMs. Every manufacturer does something a little bit different. Sometimes the buttons are a little different. Even between models in the same manufacturer, you can find some things where it's just a little bit different. You have to stop and think about it a little more than if it was just the same thing all the way across. So that means that our modern avionics require more management. And it's really a change in our role when we're transitioning from analog equipment to digital or glass equipment. We are more of a manager. We are now more managing systems. We're now having to think about, what do I need to do to get information from A to B to C and back again? And consequently, that means we probably are using the autopilot more to help us manage integrated systems. And again, knowing what those integrations are is going to be key to trying to keep you out of an accident. So how do you do this? Well, you can progress gradually, use only what you need when you need it, and then add more features as you get more and more comfortable. That's a good way to start. You can also, again, go into your AFM supplements, read those, talk to your avionics shop, talk to the tech, and practice. Remember, I talked about my colleague who uses a minimum of 5 hours VFR usage as her decision point whether or not she's going to take those new avionics into IFR or into night flight. You know, get that practice through. You know, most avionics manufacturers have apps that you can put onto your smart device, or your tablet, or your smartphone. You can work with those. You can use simulators. You can take courses. There are lots of folks out there that specialize in various types of avionics, whether it's Avidyne or Garmin or any of the others. They're willing to help you out. They spend the time to get smart on that and then transfer that knowledge to you. You can also go out with a qualified CFI or another pilot that you trust that has the same information or has a similar system that you know, and you can use them to help you learn your systems. Practice in VFR, absolutely. And then if you need to, get a ground-powered unit out and chair fly with it, plug it in, sit in the aircraft, move the knobs and buttons if you don't have access to a simulator or to an app, and do that before you fly again, night or IFR in that. When we talk about personal minimums, I talked about my former boss that didn't fly at night. The ironic thing with that is he now flies at night for a major freight carrier. So, but he was very, very strict about not flying at night because of his wife's desire not to fly at night. But that's something you should think about. If you have minimums, if you have personal minimums, and I hope everybody does, I hope you use them, I hope you review them. They will change over time. As you gain more experience, obviously you're going to increase that envelope within you can fly. As you are further away from it, that should decrease and be more conservative. You should never change your personal minimums on the day of a flight so that you can make a flight. That is not a good way to do that. If you're going to change your personal minimums, hopefully you've sat down, you thought about it, you understand the consequences for it, and then you fly another day with them. So that, I think, brings us to the end of the major points of discussion here. My behind-the-scenes person is Terry Mead. Terry is one of our writers here in ASI. Terry, do we have any questions that have come in?
Hi, John.
Yeah.
Yep. Sorry. Only one, really. It's asked in the beginning of the first discussion you had about the first aircraft. He asked, Kurt asked, was it possible that the pilot experienced fatigue, given that it was a late night flight that contributed?
That's a great question, and I think that is something that probably factored into it. I know my own personal illness. If I've been awake all day, I've worked hard, I'm not going to plan a flight in the evening or at the end of the day that I'm going to be flying somewhere where I'm flying down to minimums or where I'm getting into worsening weather. That's just not going to happen. My personal motto is that there is no flight in general aviation that I have to make, and so I will remain overnight. I'll choose another path. I'll do something different. But it's very possible that he was tired at the end of a very long day, and long flight down, long flight back. Not sure what he was doing, what kind of sleep he was able to get, how rested he was for the flight. It could be there were some fatigue issues there as well. Any other questions? I think it's I don't see any others there. Okay. Well, in that case, if you do have any questions, you see that email address on the screen there, safety@aopa.org. Please go ahead and send those in to us. We'll be happy to answer your questions if you think of any others. So let me go ahead and tell you how you can get your passport badge redeemed. If you use the AOPA pilot app, you can go in there and click on, or actually it's the AOPA app, go in and click on pilot passport. You can get to it one of two ways. Item 1 is showing the pilot passport badge symbol. You can click there, or up at the top there is the menu. You can click on that, tap on that, and that will open up a place where you can go to Pilot Passport. You see that there in the second panel. Item number 3, once you've opened Pilot Passport, you can open My Pilot Passport. And then in the third panel, you can see down at the bottom of that page where it says My Points and Badges, there is a section there for redeeming the affiliate code. And that is where you'll want to put the code, which is at the top of the screen here, ASI Web 102022102022, today's date. That is available to you until November 30th. You can go ahead and type that in the spot for item 5 and then click on the green bar to redeem the code, and that will take care of that for you. Let's see, if you want to add this webinar to your ASI transcript, you can get a certificate of completion. You can enter the following URL in your browser, and that will take you to your ASI transcript page. So https:/bit.ly/ftech3cert. Neither of those two codes that I've just given you, either that web address or the webinar badge code, equate to Wings credit. Wings credit, that is done via your email address. And again, if you need to send us your FAA safety.gov email address, your account address from there, please put that in the question page, or you can send it to us at safety@aopa.org, and we'll be happy to take care of that for you. As you may know, ASI Safety Education is funded primarily by contributions from pilots like you, aviation enthusiasts and pilots. We really appreciate those donations. If you'd like to help us, you can visit the AOPA Foundation, go to aopafoundation.org, click on the donate link, and there are plenty of options for you to be able to donate towards aviation safety. You can also donate towards the You Can Fly programs, flying clubs, our STEM initiative in the high schools, flight training initiative, and there's just a bunch of good things there that you can be a part of. Hopefully you're already an AOPA member. We really appreciate that. If you're not and you enjoyed this webinar and you want to get more access to more webinars like this and also to other good safety information that the AOPA Air Safety Institute produces, you can become an AOPA member today by going to aopa.org/join today and become part of the world's largest general aviation organization. We'd really love to have you as a part of the family, and looking forward to seeing some of you. We'll probably see some of you down hopefully at the Tampa Hangout. If not, we'll see you at some air shows next year. You can always fly in and visit us here at Frederick. We'd love to take you around, show you the building, show you what we do, and meet some of our staff. So with that said, on behalf of Terry, myself, the AOPA Air Safety Institute, I want to thank you for watching. Have a good night and fly safe.